Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to sensors and transducers. So in this video we are going to discuss about position and displacement measurement using potentiometer. Okay, so first we have already discussed the basics of potentiometer. Now we'll be discussing its application for various physical parameters measurement. Okay, so potentiometer is basically a resistive transducer. Okay, so it is primarily used for converting linear motion or rotational motion into a voltage or current signal, and it is based on voltage division rule. So potentiometers are of two types. First, like I said, it is used for converting linear and rotational motion. So linear potentiometer to convert linear motion into voltage or current signal, and rotary potentiometer to convert rotational motion, 360-degree motion, into voltage or current signal. So the basic design, the basic construction, it is something like this. Okay, so the basic elements of the potentiometer are: first, a mandrel, which is basically a insulated conductor with number of turns of wire wound over it. The entire wire, it constitutes closely wound. Here I have just shown it with some gaps, but it is closely wound, and the entire wire, it constitutes the total resistance of the potentiometer. So this whole setup is called as the mandrel. Okay, over the mandrel we have a arrow shaped thing connected to a rod, to a shaft, and it is free to move either way, okay, in this direction or in this direction. So this whole thing, okay, the mandrel, it constitutes, let me use a different slide, clean slide, to show. So the whole mandrel, okay, this whole mandrel, it constitutes the total resistance of the potentiometer, and this movable contact, which is called as wiper, okay, wherever it moves, wherever it is present, this is the total resistance of the potentiometer. Okay, so wherever this movable arm is present, it splits the total resistance into two parts. Let me use a different ink as well. It splits at this point, it splits the total resistance into two parts. Okay, let's say this is R1 and this is R2 at this point. So we have a voltage source connected to it. So wherever this is present, it gives us that voltage value, that signal. So the wiper is present at this position, so the output is taken as the voltage drop across this portion R2, which is equal to V into R2 by R1 plus R2. Now R1 plus R2 is the total resistance of the potentiometer. Now we know that resistance of a wire of length L and cross-sectional area A and resistivity rho, it is given by R is equal to rho L by A. So here, for the total resistance of the potentiometer, the mandrel, the resistivity is fixed, the area of cross-section is fixed, these are fixed. The only thing which is varying is the length, that is varying with the wiper position. So this is the only element which is changing. So this is used for displacement measurement. So the general setup is that this movable wiper and shaft arrangement, it is connected to the object whose displacement is to be measured. So with the change of the position of the object, the position of the wiper and shaft also changes, and this voltage signal, according to the voltage division rule, this is the voltage division rule, okay, here VR1 is equal to V into R1 by R1 plus R2, and VR2 is V into R2 by R1 plus R2. This is voltage division rule. So here the position or displacement of the object is dependent on the resistance, and this resistance is dependent on the length, the position of the wiper, which contributes to the change in the length of the total resistance. Okay, so here how it is done is that, let's say, again let me use a clean slide. Let's say we have the total length of the potentiometric conductor or resistance, that is equal to xt. Okay, so this xt centimeter, generally for small size potentiometric sensors, the length is in centimeters. So xt centimeters, let's say, contributes to the total potentiometric resistance of Rp ohm. That implies 1 centimeter will be Rp by xt ohm. And whenever, let's say, we measure a specific position from one side to the other, let's say we have 0 on this side and xt on the other, and this much position from here to here, let's say it is xi, from this position to this position. So this will be, for this much position, it will be equal to, for xi centimeter, it will be Rp by xt into xi ohm, this much, and the remaining will be xt minus xi centimeter, which is equal to Rp by xt into xt minus xi ohm, this much. So this is how it is done. So depending upon the design, this can become R1 and this one become R2, or this can become R2, this can become R1. So depending upon where the voltage output is taken, from where. Okay, so here xi becomes this much portion, this portion here, okay, this resistance, and from here it is split, and here it becomes another resistance. So this output is taken, okay, this output is taken as the output signal. Okay, so it is all depending on that, the potentiometer. So as I said, it consists, the basic design, it consists of the mandrel, the wire, the shaft, wiper, and the voltage source which provides the signal, the supply, and it is normally a DC voltage source which is used. And the resistive body of the wire is made of platinum, it is platinum, okay, platinum nickel alloy, and is wound on an insulated form. Like I said, it is insulated. And the resistance wire is made of cermet, carbon film, or hot molded carbon. Okay, and it is based on the application of the voltage division rule, as I said, and this is the voltage output. Like I said, the output signal is given by Rp into Xi by Xt by Rp, which is the total thing, into Vs, the supply voltage. Vs is the supply voltage. Okay, and the sensitivity, which is the change in output to the change in input, that is output by the supply voltage signal. Now, this whole potentiometric setup, this is the basic design, and another thing is this is the linear potentiometer and this is the rotary potentiometer. Same thing, but here the mandrel is circular or oval in design, circular basically, for whole 360-degree movement. Again, wire is closely wound on an insulated former, a supply voltage is given, and the rotating wiper or shaft, it is free to rotate 360 degree. So here it is used for measuring the angular displacement. Okay, the angular displacement. So here, depending upon the position of the shaft and the rotating wiper, again the total resistance, which is basically the circular thing, is split into two parts and we get the signal. Same principle, but that is for linear displacement, this is for angular displacement. Okay. Now, how it can be used for different things. First, as I said, the first way of measuring this is for to and fro motion measurement. So let us say we have an object which is placed in the center position and it is free to move either to the left or to the right. So depending on that, we can measure, we can place two potentiometric sensors on either ends, and whenever the object strikes the wiper, this is the wiper, the movable arm or wiper, shaft and wiper arrangement. So whenever it strikes the wiper undergoes a change in its position and that produces a voltage signal at the output. So this is for to and fro motion arrangement, like a simple harmonic motion. Okay. Then another arrangement is continuous position tracking and also measuring how much the total displacement of the object it has undergone. So here we place a series of potentiometric sensors at fixed separation gaps. Let's say we have the object here and let's say it is along the positive x axis. So x is equal to 0 meters, here x is equal to, let's say, 2 meter, here x is equal to 4 meter. Like that we place potentiometric sensors at fixed separation gaps. So whenever the object moves, this is the wipers, okay, wiper. So whenever it strikes the wiper undergoes a change in its position and it produces a voltage signal. So like this we can get the instantaneous position of the object and also determine its total displacement. Let us say the object is at this position. So here the instantaneous position is that x is equal to 2 meters and the total displacement is 2 meters. At this position the instantaneous position is 4 meters and the total displacement is 4 meters, like that. And last we use the rotary potentiometers for angular displacement measurement. We can use rotary potentiometers directly, or if we are using linear, sometimes we cannot design a rotary potentiometer for such large size. So what we do, we can use for small size measurements, we can use rotary potentiometers directly. In other cases, what we have to do, we have to place potentiometers, whether it is linear or rotary, at certain positions, and then this is the rotating object. So whenever the object rotates, it strikes the wiper which are placed at different positions. Let's say the angular positions 0, 90 degree, 180 degree, 270 degree, and then 360 degree here, like this, 0 degree or 360 degree. So whenever it strikes, it rotates and it strikes a particular wiper, these wipers, that particular sensor is triggered and gives the instantaneous position of the object and the total angular displacement, like that. And for more precise measurements, we can place more sensors at in between positions, here like this, here, 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 like this we can place, so that we can get more accurate and precise tracking of the position of the rotating object. So this is the basic principle of use of potentiometric sensors for position and displacement measurement, for to and fro motion measurement, and for continuous position and displacement tracking and angular position and displacement tracking. Okay, so let us try to understand this whole thing from a three-dimensional perspective. So this is a linear potentiometer, the design we have seen. So here this is the shaft and wiper, the movable shaft and wiper. So this is connected to the object, so displacement is to be measured. So whenever it undergoes movement, the wiper, it undergoes movement along with it. Along with this, the black wire also moves. So whenever it moves to a certain position, from that position, the total potentiometric resistance is split into two parts from this position. From this position, the total potentiometric resistance is split into two parts. Okay, so this is one part, let's say it is Rx, and so the remaining will be Rp minus Rx. Also, as I said, the total length is xt, so depending upon the instantaneous position, it is given by this, the instantaneous position xi, the resistance Rx is given by this. So like this the whole thing happens, and as a result, through voltage division rule, through this DC voltage source, we get the output signal. Same is the case for the rotary potentiometer. So here this is the rotating shaft and wiper arrangement. So as this thing rotates and moves to different position, so does the black wire, and as a result this whole resistance is split into two parts. Okay, and as a result, the same principle for the total circumference of the potentiometer, which constitutes the total length, depending upon that length, the resistance is split into two parts accordingly, and according to voltage division rule, we get the result, the voltage output signal. So the different things that are used for measuring the to and fro motion arrangement, where we have two potentiometric sensors on two sides. So whenever it strikes one side and the other side, the particular sensor is triggered. Okay, when it strikes this, this side is triggered. So kind of simple harmonic motion arrangement. Then we have the continuous position and displacement tracking. So this object, it moves, let's say, along the positive x-axis, and as it moves and strikes the different positions, the particular sensors are triggered, which are placed at fixed separation gaps. Okay, so this is the continuous position and displacement tracking, and then we have the rotational angular displacement or angular position thing. So here this is the rotating object, the position of which, the angular position and displacement of which is to be measured. So as it rotates and strikes the different sensors that are placed, the particular sensors are triggered, which are placed at different angular positions, like I mentioned, 0 degree, 90 degree, 180 degree, 270 degree, again 360 degree, right? And also we can place the sensors at different positions in between also to measure more accurately and precisely the position. Okay, like this we can measure the place the sensors also in between. Okay, so this is the whole principle of position and displacement measurement using potentiometric sensors. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.